So this is the next question from CAT 24, the third slot. Please pause and try it once and you can resume for the solution. So Aman invests rupees 4,000 in a bank at a certain rate of interest compounded annually. So we have annual compounding here. If the ratio of the value of the investment after 3 years to the value of the investment after 5 years is 25 is to 36, then the minimum number of years required for the value of the investment to exceed rupees 20,000 is. Let's call the principal of rupees 4,000 as P for time being and the rate of interest as R for time being. Then the amount after 5 years will be P into 1 plus R by 100 raised to 5. Similarly, the amount after 3 years would be principal into 1 plus R by 100 raised to 3. The next step, we are going to divide these two. On the left hand side, I will have amount after 5 years upon amount after 3 years will be equal to P and P will get cancelled out and 1 plus R upon 100 raised to 5 will get divided by 1 plus R upon 100 raised to 3. Effectively, I will have 1 plus R upon 100 raised to 2. The question gives us the value of A5 upon A3. The amount after 5 years upon the amount after 3 years would be 36 upon 25 as per the question. So now the right hand side 1 plus R by 100, the whole raised to 2 is actually 36 by 25. We'll take square roots on both sides. When I take square roots on both sides, we will get 6 by 5 is equal to 1 plus R by 100. So we can further simplify this and say 6 by 5 minus 1 or 1 by 5 is equal to R by 100, or I will simply get R as 20. The rate of interest in this question is 20%. And now finally we have the principal 4,000. The rate of interest is 20% per annum compound annually and the amount should be greater than or equal to 20,000 as per the question. How much is the time period or number of years required N? So the amount will be principal into 1 plus R by 100 raised to N. 1 plus 20 upon 100 raised to N should be greater than or equal to 20,000. Now I'll divide both sides by 4,000 and the 1 plus 20 upon 100 raised to N can be simply written as 1.2 raised to N. So 1.2 raised to N will be greater than or equal to 20,000 divided by 4,000 will be 5. So now one way is you can approach this problem henceforth manually. You can plug in the value of N and find out what value of N gives you 1.2 raised to N greater than or equal to 5. So 1.2 raised to 1 is equal to 1.2 only, which is not greater than or equal to 5. Similarly, 1.2 square will be 1.44, not greater than 5. 1.2 cube is also 1.728, not greater than 5. 1.2 raised to 4, for this we can use the calculator now, 2.073 approx. So again this is not greater than 5. If I try 1.2 raised to 5, this will be 2.073 multiplied by 1.2, which is 2.488, again not 5. 1.2 raised to 6 will be 2.48 into 1.2, that's 2.98, again not equal to 5. Again not greater than 5. You can do 1.2 raised to 7. 1.2 raised to 7 is 2.98 into 1.2, that's 3.58. Not greater than 5 though. Into 1.2 will give you 1.2 raised to 8. This is 4.299 or 4.3, which is again not greater than 5. Next step, you find out 1.2 raised to 9 and 1.2 raised to 9 is 5.19. Exactly what you want. The value 1.2 raised to N should be greater than or equal to 5. So 1.2 raised to 9 satisfies the given condition. Comparing N with the power of 1.2 here, N is basically 9. So that was one way of approaching the problem manually, putting in the value of N and trying to figure out what could be the number N that satisfies the given relation. A slightly better or logical way of looking at this would be, we must know that 12 cube is equal to 1728. So 1.2 cube should be 1.728. So if N was 3, it would still be 1.728 but not 5. If I multiply this again with 1.2 raised to 3, it would be 1.728 into 1.728. So roughly 1.7 into 1.7 would be 17 square 289. So still this number would be 2.89 only, approximately 2.89 only, which is not 5. Once again, if I multiply this with 1.2 cube, it will be getting multiplied by 1.728. So if you now check 2.8 approximately 1.7 times brings us very close to 5. As a confirmation, you can multiply these three now using the calculator. 1.728 into 1.728 into 1.728. Bingo, you get the same value 5.15 in a much faster way. So yes, we can now be sure that n is actually 3 plus 3 plus 3. It is 1.2 raised to 9. N should be equal to 9.